This is an ancient alien object that is rapidly approaching our sun. For the last month, all of Earth's most powerful telescopes have been focused on this peculiar light in the sky. They've been searching for answers, but what they've seen has only created more questions. Now we're running out of time. Soon the object will disappear from our sight, concealed behind the blinding light of the sun, leaving us with a cosmic mystery to unravel. So what exactly is this thing? Officially, it's called 3I Atlas, which stands for the third interstellar object. It's a visitor from one of those tiny stars we see in the night sky. We aren't sure which one exactly, but we're quite certain that 3I Atlas comes from a very old corner of our Milky Way galaxy from a distant solar system that could be twice the age of our own sun. This is only the third time we've been able to spot one of these strange interstellar visitors. The first was called Oumuamua, that bizarre cigar-shaped rock that tumbled into our solar system back in 2017. We still don't really know what Oumuamua was, but we do know it was weird, and it's already looking like 3I Atlas could be even stranger. Then came 2I Borisov, which has become the underappreciated middle child of the group. That's because it was noticeably less weird. Borisov looked and behaved just like a comet, and that is almost certainly what it was. But it was a comet that traveled here from another star, which is still pretty cool. But 3I Atlas has quickly become our best opportunity yet to study a genuinely strange, otherworldly object. This is one of those situations where the more we discover, the weirder it becomes. Officially, the object was first seen on July 1, 2025, by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, which is where its name comes from. At the time, it was located between the orbits of Jupiter and Mars, although much closer to Jupiter. We've since learned that 3I Atlas was actually spotted even earlier, on May 7, 2025, by the Transiting Exoplanet Survey Satellite, also known as TESS, which was primarily searching for distant alien planets. So it didn't actually notice our new visitor at the time. But when that initial image of 3I Atlas was captured, the object was still traveling between Saturn and Jupiter. That helps to give us a real sense of just how incredibly fast this object is moving. When NASA launched the Voyager probes on a direct course for Jupiter, it took them between 18 and 23 months to reach the planet's orbit. We know that 3I Atlas was near Jupiter in May. It's now passing by Mars in September and will reach its closest point to the Sun on October 29th. Then it will be back out at Jupiter's orbit again by next spring. That's how we know for sure this is an interstellar object. It's moving far too fast to be captured by the Sun's gravity, which is a trajectory known as a hyperbolic trajectory. Now, what's fascinating about the TESS observation is that even when 3I Atlas was out past the orbit of Jupiter, it already looked very bright, and then it got significantly brighter over the 3-week period that TESS could see it. That is a bit odd, or at least it's strange compared to the comets we're used to seeing. Typically, these comets are massive chunks of frozen water, mixed with various rocks, dust, and gas from the outer reaches of the solar system. And then as that ice gets closer to the Sun, it heats up and begins to melt. Now in the vacuum of space, this process is technically called sublimation, because liquid can't exist in a vacuum. So the ice turns directly into gas. And that's what creates the big, bright, fuzzy halo around the comet, which is technically known as the coma. This is important because our typical water-ice comets won't get warm enough to sublimate and form their coma until they've passed through Jupiter's orbit and are approaching the asteroid belt. But when TESS first spotted 3I Atlas on May 7th, the object was still way out on the other side of Jupiter. Yet it was already incredibly bright and getting brighter every single day, which shows that sublimation had already started. Based on this, we know that if 3I Atlas is a comet, it's very different from any we've ever observed. It's even wildly different from Oumuamua, which was famous for showing no visible signs of sublimation at all. No coma, They're like total opposites. And it's also different from 2I Borisov, because Borisov did all the usual things we would expect a comet to do. So it was strange in how familiar its behavior was for something so unusual. But as we continued to observe the approach of 3I Atlas throughout July and August, it just kept getting weirder. The coma around the object began to form a tail, which is a normal thing for a comet. But the one around 3I Atlas started growing in the wrong direction. It was pointed toward the sun. We know the sun is the main source of light, heat, and energy in our solar system. But we also have to think of the sun like a giant fan. It's constantly blowing out a solar wind. And this is typically what gives a comet's tail its shape. The solar wind pushes back the rapidly expanding cloud of gas and dust around the ice to create a long trail. It's like when a dog puts its head out of a car window and the air pushes their face back. It's so cute. Now try and imagine if the dog stuck their head out and their face stretched forward instead. That wouldn't make any sense, right? And that's why people were so baffled when it started to look like 3I. Atlas's tail was forming in the direction of the sun against the solar wind. These are just some of the many questions astronomers were trying to answer when they decided to point the world's most powerful space telescopes directly at 3I Atlas. That included Hubble James Webb and Sphere X, which is this crazy cone-shaped satellite that studies the universe's origins. And TESS was also brought in to take a second look at 3I Atlas as well. It was NASA's most advanced observatory that was able to provide the best insight so far into what 3I Atlas really is. And again, we have some answers, but also new questions too. The biggest discovery was that the coma surrounding 3I Atlas is made almost entirely of carbon dioxide, which means this object isn't a large chunk of water ice like the comets we're used to seeing. Although it does contain some water, the ratio of CO2 to H2O is measured at 8:1. This essentially means there is 16 times more CO2 in this object than what you would expect to see in an average comet. The cloud of CO2 around the object is now believed to be gigantic, with a radius of up to 300,000 kilometers. That's almost half the size of the sun. It's way bigger than what we anticipated based on those initial observations in July. And that also has observers thinking that the solid object at the center of the cloud might be a lot bigger than they initially thought as well. At first, we believed the core of 3I Atlas might be up to 20 kilometers wide. Then that was scaled back to possibly 11 kilometers. But now, based on these new observations, it's thought the true size could be as large as 46 km across. That's big, but it's not massive. We have discovered comets in our own solar system with cores over 100 kilometers wide. But the immense amount of CO2 compared to the small amount of water is something we've never witnessed before. It's basically the exact opposite of what we would expect to find in a comet's halo. So it tells us that this object was formed in a star system that had very different raw materials than our own. The ratios are all wrong, which is what makes 3I Atlas so genuinely alien in nature. But was it made by aliens? There was another strange discovery made this summer during an observation of 3I Atlas by the Very Large Telescope in Chile. Yeah, that's the real name. It really is very big. In any case, the VLT was able to detect the presence of nickel metal in 3I Atlas's coma, but it could not detect any trace of iron metal. Confused good. Iron and nickel are natural partners. They are the most common heavy metals in the known universe, and that's because they are forged in the hearts of dying stars and then blasted out into space by the power of supernova explosions. It's epic. Because of this, iron and nickel are always found together in cosmic places, like asteroids, moons, and planetary cores. The only time we ever see nickel by itself is when we, as in humans, deliberately separate the two metals in an industrial process. So how did nickel get into a comet without bringing any iron along with it? That's a great question. We don't know. It's pretty odd. So of course that leads us to everyone's favorite explanation, aliens. There is no shortage of theories about what kind of artificial spacecraft we might be looking at. And to be fair to those theorists, they aren't just making things up. All they do is take the known data and offer a slightly more speculative interpretation. For example, we know that 3I Atlas got brighter as it flew past Jupiter. Yes, it was getting closer to the Sun, but that doesn't account for anywhere near the amount of added brightness. So this could be explained by early sublimation due to the object's unusually high CO2 content, or it could be an alien space probe that started switching its lights on. We've also seen the theory put out there that the object is surrounded by a cloud of CO2 because it's a giant spaceship full of living organisms that are breathing out CO2 just like we do, and they are venting the waste produced into space. I've even heard it said that 3I Atlas might be a giant living organism itself, consuming dust and gas as it travels through the solar system and releasing CO2 as an organic byproduct. And the great thing is that as of right now, no one can say with 100% certainty that this is not true. It's probably not, though. The same goes for the nickel metal. No one can say for sure what's happening with that discovery. So you can't definitively say that it's not an artificially constructed alien spacecraft. Again, it's probably not. But, and this is why scientists and astronomers are quickly trying to learn as much about 3I Atlas as they can in the small window of time that we have available. We have an opportunity to get a photograph of this object as it passes close to the planet Mars in early October, coming within about 28 million kilometers. That is still pretty far, but it's close enough for 2 European Mars orbiters to get a decent view. The European Space Agency will use both the Mars Express and ExoMars Trace gas orbiter to observe 3I Atlas using high-resolution cameras and color imaging systems. Now, it's not like we'll get a stunning close-up or anything, but there should be just enough resolution to distinguish between the cloud of gas surrounding the object and whatever is at the center of that cloud. So we might get an idea about the actual shape of the object. Then, by late October, from our perspective on Earth, Atlas will pass behind the Sun, and we won't be able to see it again until December, at which point it'll be on its way back out of the solar system. But we'll get one last chance. On March 16, 2026, 3I Atlas will fly past Jupiter at a distance of 53 million kilometers. That's still pretty far away, but we do have one active probe out there in Jupiter's orbit. It's called Juno. It's an older spacecraft that has been in the Jupiter system since 2016, and the end of its scientific mission is actually scheduled for September 2025. NASA was planning to simply crash the probe into Jupiter to dispose of it and see what happens along the way. But another potential end-of-life mission could be to try and intercept 3I Atlas on its way out of the solar system. So as strange as it's been studying this object so far, we are not done with it yet. There's still so much to learn. We will get some answers. We'll probably also get just as many new questions. And that is what makes this all so thrilling.